It is the predominant sense we use when we are born. 2% of our genes are devoted to it. When we get old, the loss of it can be an early warning of Alzheimer's and Parkinson's disease. It is our sense of smell. My name is Agnes. I'm a graduate student in Northwestern University Interdepartmental Neuroscience program. I study the brain mechanism of how we make sense of odors. When we take a breath through our nose, the odor molecules carried by the airflow travel to the back of the nose, where there is a layer of olfactory receptor neurons, special neurons that can detect odor molecules and send signals into the brain. But how does the nose know the difference between odors? It turns out humans have around 400 different types of olfactory receptors. So molecule A might trigger receptor types 1 and 7, and molecule B might trigger receptor types 5, 39, and 150. It's like each odor gets an ID with a combination of codes, which allows us to distinguish a wide range of odors. Once triggered, the signals travel to multiple regions of the brain. The first step is the olfactory cortex. Using MRI scanning, we can see the olfactory cortex is more active when we smell odors versus resting. When we look closer, we can see that the activity is not uniform across the olfactory cortex, but renders specific spatial patterns. In other words, when we smell different odors, say lemon or rose, there will be specific lemon pattern or rose pattern showing up in the brain. Therefore, we can read what a person is smelling by scanning his brain, just like we can read information by scanning a QR barcode. We are still trying to complete the story of the sense of smell. How do certain smells remind us of our childhood? Why is it susceptible to Alzheimer's disease? Can we digitize odors in the future and send smell messages through our phones? These are some of the questions to be answered in our lab.